there we go. Okay. Um, all right, everybody. Thank you very much for joining us for our presentation, Generating, Maintaining, and Serving IIIF content at Yale. I suppose, though, we could have called it Collaboration and IIIF Everywhere. We'll each give a brief introduction. My name is Jeff Campbell. I'm the Associate Director of Digital Asset Technologies, part of Central IT, and my group serves the common technology needs of the university's cultural heritage organizations. Seong, can you introduce yourself, please?
Yeah, hi, my name is Seong. I'm a cultural heritage developer, technical lead here at Yale, and I've been developing the content delivery system for the Yale museums.
And Michael?
Yeah, hi, I'm Mike Appleby. I am director of the software engineering team at Yale Library, and I'm also one of the IIIF specification editors.
So in this presentation, we will not be showing you annotations, we will not be showing you deep zoom, and we will not be showing you JSON. Rather, we're going to be providing a high-level overview of this major collaboration at Yale. We'll introduce you to our collecting organizations, the two primary IIIF implementations, a little bit of detail on the implementations, and what we're working on next. But the real key component to all of this, and the real thing to focus on, is this strong collaboration that is taking place. The four primary collecting organizations at Yale have been fostering a strong collaboration for almost 15 years. This has allowed the units to productively work together to tackle common technology needs, allowing for more robust solutions and achieving greater economies of scale. But first, an introduction to the organizations. The museums consist of the Yale Center for British Art, which houses the largest collection of British art outside of the UK. The initial collection was created by Paul Mellon and willed to Yale after his death. The collection's expanded since then. The Yale University Art Gallery, which is one of the largest university art galleries in the US and started in the 1700s. And the Yale Peabody Museum of Natural History, with vast collections ranging from dinosaurs and minerals, butterflies and plants, to anthropological collections. The museums have one implementation of IIIF, which is supported by my team in Central ITS, and which leverages the museum's shared digital management ecosystem. Michael.
Yeah. Yale Library is quite large. There are about 15 libraries, individual libraries that make up the entire system. These range from our sort of general collections library, the Beinecke Rare Book and Manuscript Library, which is the picture in the center, to our departmental libraries like the Divinity School Library, which you see on the right-hand side of your screen. We are now building what is our sort of third, as I think about it, is really our third generation digital collections platform. And the URL is up there on the screen. We are migrating content from a Hydro Fedora platform mostly that in turn serve to centralize a lot of our digital collections from sort of bespoke grant-funded platforms that were built in the sort of 2000s. So we're a diverse organization, lots of digital collections over the past couple of decades that have been built, and we're now kind of moving toward finally a system-wide IIIF implementation.
At a very high level, the museum's DAM ecosystem, yes, the jokes always write themselves. The DAM ecosystem looks like this, where each of the museums manage their collections within their collection management system. The CMSs are the system of truth where the content is tightly controlled and the access is limited. Each museum has their own image capture workflows, which are unique to the needs of their collections and include both bespoke and commercial solutions. The museums are responsible for pushing data and copies of the master images to Traffic Manager, or TMAN. TMAN is a custom workflow application which manages getting master images and metadata into Preservica, which is the preservation dam, and 4K derivatives of the masters into NetX, which is used as the professional dam and is accessed by curators, exhibition, and communication staff. The museums also publish data which goes into our content delivery service, or CDS2, because it's version 2 of this system. And that leverages the data that's pushed along with metadata from TMAN to generate pyramidal TIFFs and IIIF manifests. The content delivery service provides the IIIF content that each of the museums use for their collections portal.
So the library has, in some ways, similar challenges to what the museums face, in that we have multiple catalogs. So we have archive space running. We use Voyager as our integrated library system, or ILS. And we also have our legacy digital platforms. The one we call Find It, actually, although it would ingest records from the other catalogs, allowed for a sort of custom cataloging to be layered on top that was never reflected back into the other systems of record, really. So as we're moving forward into our new development, we have a need to sort of aggregate metadata from those systems. In this diagram, I've tried to sort of tint in green our metadata focused systems as opposed to the digital assets. So we also have to, of course, assemble our digital assets for our new platform. And so we're bringing them from our legacy DL systems. And we're also, as part of this work, implementing Gooby, which is open source software, but it's supported by a company called Entranda, used for studio workflow management and so forth. So we're leveraging that to package content and replace legacy homegrown systems for digital studio work. We've also integrated or starting to integrate Preservica into our workflow, and we're still thinking about the various roles that preservation system will play in our asset management. But all of this leads to getting the digital assets into our digital collection systems management tool, along with the references to the catalog metadata. And from there, we can index the metadata and make the images available via a IIIF server that sits next to our collections user interface.
And Seong?
Yeah, so implementation choices for both groups. The museum on the one hand and the library on the other are currently two distinct systems mostly, but they share a very similar set of technical choices. So first of all, IIIF obviously utilizes the image presentation and search APIs. And the image format for the IIIF image servers, we take pyramidal TIFF as the source images. And for hosting, we use extensively the AWS cloud with the, throwing out names here, ACS, Fargate, SQS, RDS, S3, EFS, CloudWatch. And also infrastructure as code, such as Terraform in museum's case and custom tools at library. And for the image server, we use Cantaloupe. And programming language, it's kind of open. We use whatever is necessary. We took up Go at museums and Ruby and other things in the library. And we also use some of the activity streams, leveraging activity streams protocol for metadata harvesting for CDS, the content delivery for museums. Next slide, please. So this is the kind of an architecture diagram. It is a challenge to fit a big system into a single slide. So we ended up splitting it in two diagrams with some further simplification. This diagram focuses on the flow of the business data, that is image and metadata. So there are two major flows, one for the images and another for the object metadata. And for the images, so this light gray area is the CDS2 proper system. And the T-man, as Jeff explained, it was on the left side is the existing workflow managing systems that takes data from the museums and load the central dam systems, and also CDS, which is content delivery service, which faces the public, meaning both the Yale community and the world. So the image flow, it goes, so T-man uploads images and metadata to the staging area on S3, and the scaler task takes it and processes the images to produce the derivatives and send it to the image storage on S3. And those images on the image storage are consumed by the IIIF image server as the source images. And it, of course, it maintains its own derivative cache on the image server. And the other flow, the object metadata, it gets ingested through activity stream from the unit, and the metadata harvester is taking care of it. And so it ingests data and they populates the database, and the manifest ultimately goes to the manifest builder, which builds the IIIF manifest and stores them on S3. So the right most column, the light blue components are the public-facing web servers to images, IIIF image server and IIIF manifest server. Also, there's a server that serves some non-IIIF assets like stock TIFF files and thumbnail images and so on. So next slide. So this is kind of a physical architecture. Just this one lists all the components without arrows. The arrows focus on the controls, and we introduced the SQS, the message queues here. We use we make a heavy use of SQS to control the workflow. So basically, yeah, and the scaling factors are of interest here. So the controller monitors the activity stream of metadata, and if there's a change, it brings up other texts. So apart from the three public-facing web servers on the right column, the controller is the only one component that constantly is up. Other components are brought up on demand by CloudWatch monitoring the SQS message queues. So scaler, the image processor, is a very compute intensive task, so it scales from 0 to 6. And the metadata harvester, and the manifest builder, they're just 0 to 1. They're brought down when it's not used, and they're brought up when it's used. And the image server, of course, is the other hardest hit. I mean, the CPU intensive and memory intensive servers, so it scales from 4 to 8, and utilizes the shared image cache on EFS file system. So yeah, I guess that's it. So next.
So this is an overview of mainly of the AWS components for the library system. There's a lot that's similar. Some things are slightly different. I'll go through. Let's see. The top tier is basically our user interfaces and public-facing servers. We have Cantaloupe for IIIF image support. We have also Blacklight for our public user interface. both of those are set to auto scale. And then we also have a completely separate management tools interface that's staff only, only for campus users. In the middle tier, we have our workers. These are all contained within our ECS, or Elastic Container Service cluster. So they're all sort of Docker images being spun up in these tasks. We have a queue worker, and then we have a specialized worker for PDFs. So what we're finding is when you get to sort of 1,000 to 2,000 page objects, your resource demands are really high on the server, and those jobs don't necessarily coexist well with many other jobs doing image derivative generation, for instance. So we split that out as a separate type of task with its own worker nodes. The queue workers, you see they have a slightly different icon. Those are EC2 instances because they're actually using NFS to mount TIFF storage that's on campus. It's not part of AWS. The others are all Fargate serverless instances. We've got PTIFs that are generated, as well as OCR that would be uploaded, stored in S3. And at the bottom level, you see our Postgres and Solr. We're not using RDS, we're using Postgres Docker, spun up from Docker within our cluster. And both of those are writing to EFS for their file store. So that's the overall AWS design.
Sorry, just a 2-minute warning.
Mm-hmm.
Just for, simple numbers for its worth, what it's worth. Volume of content, we have 1.2 million objects in the database for museums, and 11 million images. But that includes all the derivatives. Like the proper like content images would be 1.4 million about, and so the images have about 10 terabytes in S3 storage. And typical end-to-end image ingest workflow can take about 1,000 images per hour. And metadata harvest manifest update workflow can take about 19,000 objects per hour.
For the library, we have about 3.3 million images in there. Not a whole lot to say about timing. So go ahead, Jeff.
So the highlight of what's been taking place at Yale is the collaboration. One bit of collaboration begets another and leads to bigger and better things. All of the museum catalogs are moving to the IIIF service. IIIF Everywhere enables the conversation around new tools for teaching and learning with Yale's collections. What started years ago as a way to best address common DAM needs and a search portal led to the adoption of IIIF. IIIF led to additional conversations around a discovery platform. These conversations have expanded to include metadata harmonization across the units and the introduction of linked data at an enterprise scale, which will in turn lead to additional tools for teaching and learning and greater exposure and use of Yale's collections. Small successes build on each other and lead to greater trust and collaboration. And with that, we turn it over to you all for 20 seconds of Q&A.
The nice thing, well, first, let me say thank you, folks. Jeffrey, Mike, Seong, really great holistic view into all the work you've been doing. I think we're gonna have to end the recording here, and but if folks can put their Q&A on the Whova platform, maybe you all can take a look there and answer some questions either in the chat or in the Q&A section. But we do need to wrap this one up so we can move on to some of our other sessions. But thank you, folks, for presenting. Thanks all for joining. And take care.
Thank you.
Thanks.